Hi everyone, in this video we are going to discuss the P3 difficult paper 1. So make sure that you have tried all the questions before you watch the video, so it will be helpful for you to at least try once first. Okay, so let's start with question 1. The equation of a curve is y equals to sine x over 1 plus cos x given the interval from negative pi to pi. Show that the gradient of the curve is positive for all x in the given interval. So which means that we might need to find out the gradient function first, which is by doing the differentiation. Okay, so yeah, you can see sine x over 1 plus cos x. In this case, we might need to use quotient rule. So let's copy the equation first. So y equals to sine x over 1 plus cos x. Okay, so dy dx, in this case, we need to use quotient rule, so which means that v du dx minus u dv dx. Yeah, if you are familiar with this, then do not really need to copy the formula again, but yeah, just for me to explain here. So the u over v, right? So v that we have 1 plus cos x. So du dx, you differentiate sine and you get cos x. Okay, minus u in this case is sine x. So dv dx. So differentiate the denominator. So you have 1 becomes 0, cos x become negative sine x. Okay, and then over the whole thing, v square. So 1 plus cos x square. Okay, so after we reach here, then we can continue, expand the numerator first. So in this case, we have cos x plus cos square x and then plus sine square x. Okay, so you can see sine square plus cos x, then the next thing, cos square plus sine square. So later we can try to use identity and change it to 1. So 1 plus cos x square. Okay, so cos square plus sine square gives us 1, so which means that we also have 1 plus cos x in the numerator, and then 1 plus cos x square. Okay, so the whole thing factorized, so this is like power 1, right? So after we cancel off, then we have 1 over 1 plus cos x. Okay, so in this case, we need to prove that this thing is always positive for all x in this interval. So which means that we might need to start from the interval given here. So from negative pi up to pi. Is there equal sign? No. Okay, so we know that for sine x, so you can try to draw the graph because you might be very familiar with 0 to 2 pi, right? Then if let's say negative pi to pi, so don't worry, it's just going to be the same. So if you are not sure about that, then you can try to draw the cos graph. Okay, so you know for normal, then it will be something like this, right? So this is like your 2 pi, then this is your pi. So we know that for cos graph is a period, so that's why it's going to be exactly same thing here. So you can imagine your negative pi is here. So negative pi is up to negative 1 here. So pi negative 1 here, the maximum that you have is positive 1. Okay, so that's why in this interval, the cos x also gives us the same thing, which is the range from negative 1 to 1. Okay, so imagine after you plus the number, and what do you have? So 1 plus 1, you get 2. Negative 1 plus 1, then you get 0. So which means 1 plus cos x will always be a number between 0 and 2. So which means if now we try to do 1 over 1 plus cos x, it will definitely going to be a positive number. So that's why in this case, dy dx is greater than 0 for all the x in between the range. Okay, so that's why it's increasing, right? So the gradient is positive. Yeah, gradient is positive. Okay, so yeah, that's how we prove that. So make sure that at the end you must reach the correct justification. So let's go through how the marks is given in the question here. So you have the first one that you need to do is to carry out the quotient rule here. So this gives you method 1. Okay, So you get your derivative, everything here. So the correct derivative, yeah. So which mean in this case, then you try to apply your identity here. So which is in this case, how do you change your cos squared plus sine squared to 1? So which means from here to here, you are using your identity. So that's why that will be your A1. Okay. Then at the end, you get this answer. Okay, then you use your method. So through this method, then you try to justify that this thing will always be a positive one, then you will get the last one. Okay, so that's basically the 4 marks in this question. Okay, so let's move on to question 2. The two variable quantities x and y are believed to satisfy an equation of the form of y equals to c a power x. So a and c are constant. Okay, so you have this pair of value. Then the question wants us to plot the value ln y against x for the 4 pairs of the value, and you draw a straight line. So the question wants you to estimate the value for c and a. Give your answer in two significant figure. Okay, so let's try to plot the graph first. So 0.9, 1.7, so it will be somewhere here. Okay, and then the next one we have 1.6, 1.9, so 1.6, 1.9. The next one 2.4, 2.3, 2.4, 2.3, and the last one 3.2 and 2.6, so which means here. Okay, so let's try to draw a straight line. Alright, so you should be able to get something similar. So make sure that your straight line is just like in the middle of the lines lah. So it wouldn't be like above the points or below the points. So make sure it's just in the middle. Okay, so the question wants us to estimate the value of C and A. So obviously you need to find out the gradient, the intercept. So the first thing that we can try to do is we change the form, the exponential graph, to be a linear graph first. Okay, so y is equal to c and then a to the power of x. Okay, so let's try to transform it to linear form first. So ln y equal to ln c a x. So split them up. So ln c plus ln a x. Okay, so just rearranging them. So x, you can move it to the front, right? Okay, so for a better arrangement, so just try to arrange it to y equals to m x plus c. Okay, so in this case, you can see that the y here is ln y and the x here is x. So as y, you are arranging it in y equals to mx plus c. So in this case, let's try to solve from the y-intercept first. So we can see is 1.3 here. So which means that c is equal to ln c. So which means ln c will be equal to 1.3. Okay, so by using your calculator and you solve e power 1.3 and you'll be able to get 3.7. The question only want your answer to be in 2SF. Okay, so make sure it must be in 2SF, yeah. So the other thing, y equals mx plus c, so your gradient will be equal to ln a. So in this case, ln a will be equal to, same thing, let's try to pick 2 points from the graph. So please do not try to take the point where you plot the graph, because if you do so, then it will lose the meaning of drawing this straight line graph already. Because ultimately, why you want to draw the graph? Because you want to get the general gradient for the graph. If you are using all these points, then why not you straight away take the point from the table? You get what I mean, right? So as why in this case, maybe you can try to use the point here and the point here. Okay, so in this thing, then we can have, oh yeah, it'll be good that you try to draw a triangle, do not like plot like what I did here, because I can't use like the ruler to draw the line, so it'll be a bit difficult. So yeah, what I did is just like this. So which means in this case, I will have 0.5 and 1.5. So for this one, then I have 3 and 2.5. Okay, so let's try to find out the gradient. So 2.5 minus 1.5. Okay, and then divide by 3 minus 0.5. So in this case, we have 1 over 2.5, right? So 1 over, 2.5. Okay, so 1 over 2.5, that will give us 0.4, I guess. Yeah. Okay, so 0.4. So same thing, solve for A. So in this case, then we have A is equal to e to the power of 0.4. So same thing, change it to 2SF. So it's 1.5 into significant figure. Okay, so that's how you answer this question. So this is like, I mean, logarithm relationship, we try to change it in linear form. Okay, so the marks of this question will be given in a form where you successfully plot the 4 points, then you draw the straight line, then you can get the first mark. Okay, then after that, you state that y equals to mx plus c, so which means that you'll be able to get this thing, then you can get 1 mark. Okay, so you use the correct thing, so which means you identify that you use this thing and you use this thing, then you'll be able to get the method mark. Okay, so intercept equals to sine ln c, then gradient equals to ln a. Then after that, at the end, you will be able to get every answer, then you get each 1 mark for your last answer. Okay, so for this question is 5 marks. Okay, so let's move on to number 3. Okay, number 3, it is given that x equals to ln 1 minus y minus ln y, where y is in between 0 and 1. So show that y can be written in this form. So this is a question regarding the indices and logarithm as well. So let's try to copy the question first. You just need to do some rearrangement here. Okay, so the first thing that we can try to do is we can combine these two terms as one, right? Because it's minus. So we know that ln A minus ln B can be written as ln in bracket A over B. So it's the same thing here. So what we can try to do is combine them ln. So 1 minus y over y. Okay, so bring the ln to the other side. So we have e to the power of x will be equal to 1 minus y over y. So in this case, you can see that this is e to the power of x, but what you need to show here is e negative x. So you can imagine what the question trying to do here is that you might need to flip the fraction here to the other way around. So which means e to the power of negative x will give you y over 1 minus y. Okay, so I hope that you're okay with that. So which means if let's say I say that x power n is equal to a over b, right? Then which means that x negative n is equal to b over a lah. Yeah, because negative, which means negative 1, so 1 over. So when you put 1 over, then you flip the whole fraction. Okay, so let's continue. So in this case, then we can move this over the other side. So we have e negative x minus e negative xy equals to y. So group all the y together, then we try to do some what is that called? Factorization. So we can have 1 plus e negative x y is equal to e negative x. Okay, so in this case, then now we can rearrange to the form where what the question wants us to do. X, so 1 plus e negative x. Okay, so it's actually quite simple for the question. So the thing that you might need to know is how to eliminate or how to bring the ln to the other side. So in this case, you have the B1 mark. Then after that, you'll be able to show the full working until the end, like how you rearrange everything. So if everything is correct and show that you get your last result, then you'll be able to get another B1. Okay, so let's move on to the next part. So hence show that when you integrate y with respect to x from 0 to 1, then you'll be able to get ln 2e over e plus 1. So we need to do integration. So b. Alright, so 0, 1, y ln x. So let's try to write down our equation here. So 0, 1. So e negative x, so 1 plus e negative x. Okay, so this is actually not a very difficult one, but yeah, you will need to know the formula so to help you to do this. Okay, so we know that, let's try to use the other color. So this is for formula part. So we know that if let's say you have f prime x, over fx, right, then you'll be able to make it to ln fx. Okay, so that's the same idea that we are going to apply in this case. So we know that if you have if your f of x is e to the power of x, right, then what is f prime x? Still remember how to differentiate this? Yeah, so you differentiate the power, so you bring it down, right? So negative x, then the power remains the same. Okay, so that's why you can see that this is actually the differentiated form for what you have in the denominator. So we can continue from there. So you might want to change it to negative. So negative 0, 1, negative e negative x. Okay, so which means when you differentiate this, then you'll be able to get this. So e negative x dx. Okay, so now this thing is in the form of f prime x over fx already. So which means we can try to integrate it, then we'll be able to get ln. So 1 plus e negative x. Okay, so you are going to substitute the 0 and 1 inside. Okay, so now let's do some substitution here. So negative ln 1 plus e negative 1 minus negative ln 1 plus e negative 0. Okay, so let's continue. So equal to, so in this case, what we have here is e to the power of, oops, let's try to do this first. Yeah, so e to the power of negative 1, you'll get some kind of number, so we just try to leave it here. So negative ln and then 1 plus 1 over e. Okay, then in this case, we will have negative become plus. So ln e power 0 gives us 1, so 1 plus 1 is 2. Okay, so in this case, when we try to combine together, we can just change this to the front. So now let's do our combination, because you see what you need to prove is only in one ln, right? So that's why in this case. Okay, so we have the ln here. So ln 2 over 1 plus 1 over e. So simplify that. So we have 2 over e plus 1 over e. So we need to bring the e going up. So which means you will get ln 2e over e plus 1. Okay, so this is how you prove and you get your last answer. I hope that you are not confused with this. Yeah, so it's basically, or you can just write 2 divide, right? So 2 divide the fraction in the bottom here. So 2 divide e plus I 1 over e. So that's why multiply become e plus 1. So 2 times e, then you get 2e. Okay, so that's the idea. How do you get the last answer? Okay, so in this case, the questions, okay, the marks will be given in a form where you have the first one, which you'll be able to know that you'll need to do your integration and to get this thing. Okay, so you can get this, you get your m1 here. Okay, then you'll be able to substitute everything, use your limit and so on. So substitute everything correctly, you get another marks here. Then after that, use your limit. So yeah, so continue to do your full working until you get your last answer. You get this one and you'll be able to combine everything until you get the last point here. Okay, then you can get your last one. So it's 4 marks for this one. Alright, so yeah, that's basically the idea. So make sure that it will be always good that you try to write it in this form, because so that you to make sure that you always have the form of f prime x over fx before you write it into ln. Okay, because sometimes you might miss out some important part where actually it's not the f prime x, so you cannot continue with integration with ln, right? Yeah. Okay, so that's basically how you solve this question. So question 4. Okay, question 4. The polynomials x, f of x, and g of x are defined as these two. So a and b are constant. So it's given that x plus 2 is a factor for f of x. That is given that when g of x is divided by x plus 1, you have remainder of negative 18. Okay, so you need to find a and b. So in this question is regarding the factor theorem and the remainder theorem. So I hope that you still remember how to do that. So let's start with the first one. So if given that x plus 2 is the factor of f of x, so meaning that when you substitute negative 2 in this function, then you'll be able to get 0. So which means in other words, the remainder is 0. Okay, so let's start with that. So substitute negative 2 and you'll get 0. So which means negative 2 power 3 plus a negative 2 power 2 plus b equals to 0. So from this, then we'll be able to get negative 8 plus 4b, plus 4a plus b equals to 0. So let's try to do some rearrangement. 4a plus b equals to 8. So that's our first equation. Okay, so move on to the second one. So it is given that when g of x is divided by x plus 1, the remainder is negative 18. So by using remainder theorem, so we know that when you substitute, sorry for that, it's g. So when you substitute the root here, which is negative 1, sorry, it's not considered a root. When you divide it by x plus 1, then you get remainder of negative 18. So which means when you substitute negative 1, then you'll be able to get negative 18. Okay, so same thing, let's do some substitution. So negative 1 cube plus b, then negative 1 square minus a is equal to negative 18. Okay, so let's move on. So negative 1 plus b minus a gives us negative 18. So let's try to arrange it a bit as well. So negative a plus b equal to plus 1, negative 17. Okay, so by solving the equation, so I guess you're supposed to have no problem in this. So 1 minus 2, then we can get 5a will be equal to 8 minus negative 17, right? So that gives us 5. Then after that, continue. So you can try to use 2. So negative 5 plus b equals to negative 17. So b will give us negative 17 plus 5, so negative 12. Okay, so that's how you get these two answer. So for this question is a 5 marks question. So the first one is you need to understand that when you substitute negative 2, then you can get 0. So which means your equation, so you get 1 here for b1. Okay, then you substitute negative 1, then the same thing, you get b1 for the other equation. Then when you try to solve it, then you'll be able to obtain the negative 1. So you'll be able to solve it. So meaning that you know you need to do simultaneous equation. So you solve a pair of linear equation, then you'll be able to get method 1, then your last answer A1 and your last answer A1. Okay, so that's basically the 5 marks. Okay, so now move on to part 2. So for B, when A and B have this value, find the greatest possible value for g of x minus f of x. Okay, so let's try to write down our function first. I guess that will be easier. So f of is gx minus fx, right? Yeah. Okay, so let's write down g of x. So g of x here is equal to x squared minus b is negative 12. So which means in this case, it minus 12. Okay, yeah, so minus 12 x squared and then minus a, so minus b. Okay, so fx here is x cubed. Then after that plus is a plus b. So a and then minus 12. Okay, so after you get this, then we will need to continue. So g of x minus f of x. So we'll be able to get x squared, x cubed minus x cubed, nothing else. So negative 12 minus 5, so negative 17x cubed. Then negative 5 minus, so plus 7. Okay, so after you get this thing, then now we can continue on like normally how we try to do this. So the question, yeah, I think is for any number, right? Yeah, but we know that for any number for x squared, when you try to be greater than, it will be a number that's positive. So if you try to multiply it with negative 17, then eventually it will give you a number that is negative. Am I right? But it can be greater or equal to 0 lah, because we can accept 0 as well, right? So when you try to times with negative 17, then it will give you a number that's negative, or the biggest number that you can get is 0. Am I right? So that's why in this case, when you try to plus with 7, so which means the greatest possible value that you can get is only 7. So which means 7. Or if you write in full, I hope that you get what I mean, right? So x squared is positive. When you multiply negative 17, it becomes a negative number. So when you plus 7, the greatest possible number that you can get is 7. Okay, so that's the idea. So for this question, I guess it's only a 2 marks question. So the thing that you need to get is to obtain negative 17 x squared plus 7. So this gives you 1 mark. After that, you'll be able to rationalize everything and get your greatest possible value that gives you a 1. So 2. Okay, all right, so let's move on to the next question. Okay, number 5, the diagram shows a triangular pyramid ABCD. So it's given that AB is 3I plus, yeah, blah, blah, blah. Okay, yeah, so it's given your AB, AC, and ED. Okay, so these are the three that's given. So question 1 is to verify showing all necessary working that each of the angle DAB, DAC, and CAB is 90 degree. Okay, so for these questions, I hope that you'll be able to relate it to the idea where if you want to prove that an angle is 90 degree in vector, then what you need to do is to prove that the scalar product or the dot product is equals to 0. Okay, so again, do not need to write the whole thing, then you prove that the theta is 90, but eventually if you know that the dot product is 0, then you should be able to know that the angle is 90. Okay, so which means that you can see DAB, DAC, CAB is basically everything at A lah. So DAC, so this is 90. Okay, so DAB, DAB, so which means this is 90. Oh, sorry, here is 90 as well. Then CAB, so which means this is 90 also. Okay, so that's the few things that we need to solve. So let's start with the first one maybe. Okay, so DAB, so DAB is here, so which means that you will need to use AD multiply with AB and try to find out the dot product. So AB, okay, and also AD. So you can try to write down everything. So AB is 311, and then AD is 14, -7. So try to write the whole working if that's possible, because the question says show all necessary working, right? Plus 1, 4, and then plus 1, -7. Okay, so after you get to this point, then it's okay for you to continue. So 3 plus 4 minus 7, then you can get 0. Okay, so which means in this case, you know that DAB is 90. Okay, so you can move on for the next one already. So for DAC, then you need to prove for AC and AD. Yeah, it's actually quite long, but I mean, this is a proving question. So it's like basically a free marks for you. Like you already know that if you're able to get 0, then the marks is yours, right? But then it's just some few things that you will need to write down. So 1, -2, -1. AD is 1, 4, -7. Okay, 1, 1, -2, 4, and then -1, -7. Okay, so 1 minus 8 plus 7, so you get 0 also. So in this case, you are proving CAD or DAC, follow the question. Okay, equals to 90. So the last one is CAB, so which mean AB and also AC. AB, AC. Right, so 3, 1 plus 1, -2, 1, -1. So we have 3 minus 2 minus 1, and that gives us 0. Okay, so in this case, the last thing just now is BACAB. So CAB is 90 also. Okay, so each of the proofs here will give you B1. So which means 3 marks. So show that is 0. But make sure that you need to have the process here. I guess if you want to simplify a bit of the step, then the first one you can no need to write. But for this part, you will need to write the whole thing. So 1, 2, 3. So that's the 3 marks for the question. Okay, so let's look at B. So find the exact value of area of triangle ABC, so which means the area here. Okay, then find the exact value of the volume of the pyramid. So eventually you can try to imagine is that if let's say these are all 90, right, then which mean this is a right angle triangle. So in another words, you can try to imagine that what you need to do is to get the, if this is 90, then you can get the height and the base, right? So which means you can get the length of AC and AB, then you can solve the area for triangle. So after you get the area for a triangle, that's basically your base area. So we know for volume of pyramid is 1 over 3, multiply the height and multiply the base area. So which means the height, because this is 90 degree, right? So DAB is 90 degrees, so we know that AD is the height. So we can find the magnitude of AD, then we'll be able to multiply the answer just now, then we can get the answer already. Okay, so let's try to do that. So this is part B. Okay, so just now the triangle is ACB and 90 degrees at A. Okay, so this is the A. Yeah, for BC is okay, just make sure it's the perpendicular 90 degree lah. So which means in this case, what we need to do is to get the height for AB first. Okay, so the height we need, meaning the length or basically the magnitude of AB. So AB is 311. So that's why square root 3 1 plus 1 square plus 1 square. So 9 plus 1, then you can get 11. So same thing for the base now. So AC. So AC is 1, -1, and -1, right? So same thing. So 1 plus -2 square plus -1 square. So 1 plus 1 plus 4, so that's 6. Okay, so area for triangle ABC is equal to half times the height times the length. So in this case, we get 1 over 2 square root 66. Okay, so now we need to find the volume of the pyramid here. So volume of the pyramid is equal to 1 over 3 times the base area and times the height. So for the base area is basically the triangle that we have, right? So yeah, you can see it from the, so this is the base, then this is the height. So we need to find the magnitude for AD now. So 1 over 3, the base area is 1 over 3 square root 66. So the height for D, AD. So AD is 1, 4, -7. So 1, 4, okay, -7 squared plus, sorry for that. Okay, so in this case, we can get 1 over 6. So 1 plus 16, 17, 17 plus 49, 17 plus 49. Yeah, that's 66. So square root 66 multiply square root 66 give you 66. So multiply by 1 over, yeah, basically this is the thing. Okay, so at the end, then you'll be able to get multiply, so it's 11. Alright, so that's how you get your answer. So in this case, then this is a 4 marks question. So the first one that you can get is if you are able to get these two magnitude, then you get the M1. So you can get the area, then you get A1. Then after that, move on, you will be able to know the whole equation here. You are writing it correctly. So the base area times the height, including how you find the height, how you times the base area, then your last answer, you have your A1, so it's 4 marks here. Okay, so let's move on to question 6. Okay, question 6. State or sketch an Argand diagram showing the region R consisting of the points representing the complex number Z, where Z is given in this inequality. So sorry, I have put in the graph because I don't want to switch over my window here. So yeah, it will be easier for me in this. Okay, so which mean in this case Z minus 4 minus 4i. So you should be able to know that this is a loci of a circle. So Z minus 4 plus 4i, okay, so lesser than 2. So which means in this case, your circle will have a center of, I mean, if you already know how to read this, then you do not really need to write. But if you are still not sure yet, then perhaps you will need to practice on that. Okay, so which means that it's a center of 4, 4. So which means basically 4. Okay, I'm just like plotting it. 2, this is the end, 6. Okay, so which means in this case we have 4 here, then 2 here, and also 6 here. Okay, so you have the center for 4. Alright, so I hope that you can get the idea. So basically 4, 4, then after that radius 2, so that's why the maximum that you have is up to 6, then 2, then 2 and 6. So this is how the locus look like. So remember the question want you to show the region of R, so which means you need to shade that, I mean the region that you have is inside here lah. So this is your region of R. Okay, so yeah, this is basically the answer for part 1 already. It's just that simple. So the thing that you need to do is show that you draw a circle here. Then you need to show that your shaded region. So basically you will get 2 marks for this question already. Okay, so the 2 marks, yeah. I don't indicate anything lah. So make sure that you know center is 4, 4. So if you can draw the line, then you can draw the line. But basically you can see the idea is center 4, 4, radius 2. So that's why you need to write down some important coordinates here. So make sure that you shade the correct region, then you can get the first mark. So let's move on to the next one. For the complex number represented by points in the region R, so this is the region, right? It is given that the modulus of Z will be in between P and Q. Then the argument of Z will be in between alpha and beta. Okay, so let's try to solve the first one first. Okay, so the idea is actually not very hard, but let me try to change it to another window so that I can try to draw some lines that it will be helpful for your understanding. Okay, let's try to look at the first part first. So the question given that the modulus of Z is in between P and Q. So P is like the shortest magnitude that you have. Q is like the maximum magnitude that you can have. So normally when we talk about magnitude, right, then which mean that, okay, for example, if let's say we have a point here is 2, 2. So when we say that magnitude for this point, then which mean that is how long is what is the distance from the origin unto the point? Am I right? So that's why you do 2 square plus 2 square then square root. Okay, so it's the same idea here. So where do you think is the point within this region that give you the minimum magnitude in this case? Then you can imagine it should be a point here, because it should be a point that's like 90-degree tangent over this place. You get what I mean? So if I were to draw a line, right, sorry for that. If I were to draw a line, then it will be something like this. Okay, so which means that at this place, this is like the minimum magnitude that I can get. Then this is like the maximum magnitude that I can get. So no matter how I draw the other line, it's going to be, either longer than this or shorter than this. So you try to imagine here. So when I try to draw a line here, so imagine the magnitude here is definitely going to be shorter than this, am I right? So that's why the P should be the length over here and the Q should be the length over here. So I hope you get what I mean. Okay, so now then look at the second part. So the argument of Z, the minimum that you have is alpha, the maximum that you have is beta. Okay, so the same thing. Argument tells us that what is the angle between with reference to the positive x-axis. Am I right? So that's why where is the minimum possible argument that you will get? It should be a place here. So it means here. Am I right? So this supposed to be the point. So which means that for this line, it will give you a smallest argument, because you can imagine if you move on for the other part, right? Sorry, if you try to move it for the other part, so you can see the argument would just look at the angle here. The angle here would just get bigger and bigger. So this is the minimum argument that you can get already. So which means it's on this line. So what is the maximum argument that you can get? It will be over here. Am I right? Because anything out of this region, so here. So because anything that if you continue to draw, then this point is no longer in this region anymore. So the maximum argument that you can get out of this region is basically at this point. Okay, so these are all the important lines that we will need. So let me try to draw like two lines, that later we will be able to use it. Okay, so this is the 4 line. Yeah, I guess this one no need to draw lah. You should be able to know like this is, because I guess it's a bit, yeah, okay, later I'll try to change this place a bit. Okay, then the other one is this thing. Okay, so this is a tangent, so that's why from here to here it will give you a 90-degree. From here to here it will give you a 90-degree as well. So later we are going to use this to help us to get our value here. Okay, so let's go back to our working. Alright, so let's look at our working here. So the first one, let's start with the P and Q thing. So this is for part B. Okay, so P, Q. Alright, so as what I explained just now, so we know that the length over here will be our P. So this is like the shortest magnitude that we can get. So this is P. Okay, then Q is like the whole thing here up to this point. So the whole thing here is Q. Okay, so now let's try to do some calculation here. So how can we get the length of P here? So you can see that our center is here, right? So it's at 4, 4. So that's why by looking at this right angle triangle, then we'll be able to get the whole length here. So if we are able to get what is the length from the origin to the center here, then minus off the radius, then we'll be able to get P lor. Then for Q, then it's the same thing. If you are able to get the length from origin to the center, then plus another radius, then we'll be able to get our Q. Okay, so that's the idea. So maybe let's try to find out the length first. So the length from origin to center, okay, then is equal to square root 4 square plus 4 square. So that is 16 plus 16 square root 32. Okay, so for P, then it will be equal to square root 32 minus off the radius of the circle, which is 2. So just by using your calculator, write down your answer in 3SF. Okay, then after that, the other thing is Q. So it will be square root 32 and then plus 2, which is 7.66. You wouldn't be able to get other length that's longer than that already, because no matter how you move around this region, it will eventually give you a number that's greater than P and lesser than Q. Okay, so these are the maximum and the minimum of the magnitude that you have for all the Z inside the region. Okay, so now let's look at the second part. So we have the argument Z, then alpha, beta. Okay, so same thing by looking at what we have drawn here. So which means in this case, we want to get this is the maximum that we have, right? Let's try to use the other color. Okay, so yeah, this is the alpha that we have. Okay, then the maximum one until this part, this will be our beta. So let's start with the alpha first. So how can we get this? So we might need to, I mean, in this case, we cannot use the triangle here, yeah, because this is not where the tangent is. But there's one thing that we know is this is the point of 4, 4. So that's why this line is like a gradient 1 line. So if let's say the gradient is equals to 1, then which means that we know that for this thing, is going to be 1 over 4 pi. So which means 45 degree is perfect half. So if we know that this place is perfect half, so which means that the 1 over 4 pi minus of this, then we'll be able to get alpha. Then we try to plus it with the other side, then we'll be able to get our beta. So how can we do that in exact? So let's try to look at this right angle triangle here. Okay, so from what we have here, right, then this thing you already know, this is going to be the radius, so which is 2. Okay, then after that, from just now, what we calculate from the length from O to C is square root 32, so which means here is square root 32. Okay, so we know that this is a right angle triangle, am I right? Because this is a tangent, so from center to the tangent, it will create a 90-degree. So that's why this is a right angle triangle, so we can get what is this. All right, so let's try to find out that first. So in this case, we have O and H, so which means shift sign. So sine -1, so that one is 2 over OH. Okay, so in this case, then we'll be able to get shift sine 2 over square root 32. So answer in radian, so 0.361. Okay, so after you get this, then now we can move on to try to find what is our value of the other side here. So which means that this is, let's try to write down 0.361. Okay, so now we know that the purple color from here to here is 1 over 4 pi, right? So that's why to find our alpha is going to be, yeah, sorry, how come I use the green color? It's okay lah. So alpha is equal to pi over 4 minus of 0.36. I guess we should write more than that, the decimal place. 2 over square root 32. So 137. Okay, so pi over 2 minus of the answer just now. Yeah, sorry for that. Yeah, so 137. Okay, then we'll be able to get in three significant figure 424. Okay, then after that, the next part, so you can see this is our beta, right? So it will be half, then you can see this is exactly the same thing. So this line is 2 as well. So that's why if you were to find out what is this, let me try to use the, yeah, if you were to find out what is this, then it's going to be the same thing, right? Opposite adjacent, so OH. So which means this blue color one is also 0.361. So how are you going to get the whole beta is by using pi over 4 then plus 0.361. So which means that alpha is equal to beta is equal to pi over 4 plus 0.36137. Okay, so when you try to plus them together, then give your answer in three significant figure as well. Then you will be able to get 1.15. Okay, so that's basically how you get the answer. So you might need more time to understand this. Basically, everything that we try to use here, right, is something that you have learned before. It's just that how are you going to apply in the question so that you understand what the question want, then you try to answer from that. So the thing that you need to do is, in your picture, they actually want you to identify the ends of diameter. So, yeah, they will expect you to draw the line, so it's like some part of the method that you show in the picture here. Or I guess it's totally fine if you replace it with this thing is like your M1, I believe. Then after that, you get your P1, you get your P and Q and that's considered as A1. So after you get it, then you'll be able to know that this is like the tangent thing. So another M1 shown here. So yeah, the first M1 is this line. Okay, the second M1 is this line and this line. So this part and this part together. Then after that, the next one is you'll be able to get this radian. So this give you a method mark. Then your last part, this give you A1, this give you A1. So for this question, total you have 6 marks. Okay, so now let's look at question 7. Okay, question 7. So this is a trigonometry question. So prove that sine squared 2 theta times with the whole thing, then you get 4 cos 2 theta. Okay, so let's straight away go into the proving part. Okay, so sine square 2 theta, let me try to copy. So it will be easier for us to start with the left-hand side lah, right? So cosec 2 theta minus second square theta. Okay, so let's try to move on. So in this case, then the first thing that we can try to do is yeah, because you can realize here is that at the end you have cos 2 theta, so which means eventually you will need to revamp the whole thing lah, even for the sine 2 theta as well. So let's try to just change everything to the basic thing, which is the sine and cos. Then after that we see how are we going to change it to 4 cos 2 theta, right? So this is sine 2 theta square, so which means that we can expand it. So 2 sine theta cos theta and square. Okay, so because sine 2 theta, sine square 2 theta basically is sine 2 theta, the whole thing square, right? So that's why this is sine 2 theta then square. So for this thing, then cosec, then we can try to change it to sine. So 1 over sine square, okay, theta minus of 1 minus cos square theta. Okay, so now let's see how can we combine these two. So in this case, for the first part here, we have 4 sine square theta and then cos square theta. So when we try to combine these two, then which means the first one we need to multiply cos square theta, second one multiply sine square theta, then we can get cos square theta minus sine square theta. Okay, over the whole thing, we have sine square theta, cos square theta. Okay, so I think things are getting clearer. So you can see sine square theta, cos square theta, sine square theta, cos square theta, that gives us 4. And what we left with is only cos square theta minus sine square theta. So by looking at the identity, then we know that cos square theta minus sine square theta basically is cos 2 theta. So we can get our last answer here. Okay, so this question, proving question, there's 3 marks here. The first one is you will need to know how to do your 1 over sine, 1 over cos. So the whole thing here, then you can get your B1. Then you know how to expand this part, then you'll be able to get another M1 here. Then after that, make sure you go through everything, you do your simplification, then you use another identity again to get your last answer. Then you'll be able to get your last one. Okay, then let's move on to part B. So hence solve for the theta between 0 and 180, the equation for the whole thing equals to 3. So in this thing, you can see is the whole thing here equals to 3, so which means that we can always change it to what we have on the right hand side, right? So let's try to copy first. Cos square theta 2 theta cosec square theta minus second square theta equals to 3. Okay, so we know sine square 2 theta cosec square theta minus second square theta, it gives us 4 cos 2 theta. So equals to 3. So which means in this case, we also know that cos 2 theta is equal to 3 over 4. Okay, so question 1 is to solve from 0 to 180. So which means if let's say theta is from 0 to 180, in the other words, then we know that 2 theta will be from 0 to 360. Okay, so by having this, then now we can try to solve. So cos 2 theta equals to 3 over 4. So by using your calculator, you should get 2 answers here. So 2 theta will be equal to, so your answer should be in degree, yeah, because they give you the range in degree. So that's why the first one is 41.41. Okay, then the other one is quadrant 4, so 360 minus 41.41, and that gives us 318.59. So divide by 2 to get our theta, and we can get 20.7, and the second one is 159.3. Okay, so that's the part for part B. So this question is having 4 marks. So the first one is to imply this thing. Okay, so you understand that left hand side equals to right hand side, then after that you replace them with 4 cos 2 theta, then you write this, then you can get your B1. So make sure you are solving everything correctly, then you'll be able to get this thing that is your M1. Sorry, you'll be able to get your first one here, which is your M1. Then after that, your second one here, your, sorry, one, two, yeah, at least one angle. So your reference angle, you get one. Then after that, A1 and A1. Okay, so yeah, that's basically the idea for the 4 marks here. Okay, so let's look at part C. So C, what do we have here? Find the exact value for cosec square 15 minus secant square 15. Okay, so this will be related to what we have here as well. So we can try to start with what we have proved here, because what you can see here is that this thing is basically what we have here. So you might need to move this to the other side. So yeah, let's try to write down the identity just now. Okay, so sine square, just copy first. Okay, so what we want is just what in the bracket, right? So that's why cosec square theta minus secant square theta equal to 4 cos 2 theta over sine square 2 theta. Okay, so the question want to find for 15. So that's why in this case, our theta is all equals to 15. So which means secant square 15 minus secant square 15 should be equal to 4 cos. In this case is 2 times 15, right? So you can get 30 divided by sine square 2 theta as well. So that's 30 also. Okay, so this is the special angle. So for cos theta, cos 30, we have square root 3 over 2. Then sine 30, we have 1 over 2. Okay, so by solving this, then we have 4, sorry, 1, 2, so 2 square root 2. School 2 square root 3 over 1 over 4. So multiply the 4 up there, then 8 square root 3. Okay, so that's our answer. So for this thing, you'll be able to identify this thing, then you'll be able to get your M1. So you get your last answer, you'll be able to get your B1. So that's 2 marks. Okay, so that's the part for 7. So let's move on to 8. Okay, question 8. The equation of a curve is x squared minus 4xy minus 2y squared equals to 1. So A, find the expression for dy dx and show that the gradient is at the point -1, 2 is given -5 over 2. Okay, so yeah, let's try to do the differentiation. So I believe that you need to do explicit here. So x squared minus 4xy minus 2y squared equals to 1. Okay, so in this case then for 4xy, then you need to carry out your product rule as well, because it involves like two variable, two function here. So x squared, then we have 2x. Okay, so product rule here, uv, so u 4x dv dx 1 dy dx, and plus v is y, du dx you get 4. Okay, then minus of 2y squared, that gives us 4y, and then dy dx equals to 0, that just equals to 0. Sorry, equals to 1, it just becomes equals to 0 after you differentiate it. Okay, so now let's do some rearrangement. So 2x minus 4x dy dx. Don't forget minus plus, so it's minus 4y minus 4y divided dx. Oh, I believe you can divide 2 for all the terms here, but just try to rearrange them first. So 4x plus 4y divided dx equal to the other part, we have 2x minus 4y. Okay, so dy dx will be equal to x minus 2y over 2x plus 2y. Okay, so yeah, it's not the end yet. You still need to show the gradient, right? So at the point -1, 2, the dy dx is equal to x minus 2 over 2x plus 2y. Okay, so -1 minus 4, we have -5. And then for the denominator part, we have -2 plus 4, we have 2. Okay, so that's how we get to our answer, -5 over 2, that proved. Okay, so yeah, this questions is giving 5 marks. So the first one is you use the product rule correctly, you get 1 for B1. Then you can get 4y dy dx, everything that's correct here, you get 1 full marks for the whole thing here, B1. Okay, so make sure you are able to rearrange everything to dy dx, and you'll be able to get M1. Substituting everything here, then you'll be able to get your another M1 here. Sorry, I think they give, oh yeah, here you got 1 B1 as well. Okay, then after that, until the end, you substitute correctly, then you get the answer, then you got the last mark, so 5. Okay, so which means product rule you get 1, implicit you get 1, then the whole thing is correct, then only you can get another B1, so which means here. So rearrange everything you get and one substitute until you get the last answer, then you can get the last marks. Okay, so now part B. So show that the curve has no stationary point. So for this case, same thing, we need to look at our dy dx. Oh yeah, I guess in this case, we can't use what we did previously because you do not have any exponential curve involved here. So which means that the thing that you need to prove is dy dx will never be equal to 0, right? In this case, because it's x over 2y, so which means in another words, you need to prove that x minus 2y will never be 0. So in this case, you'll realize here that the question didn't give you any information for x and y, so basically you can't do that. So you can imagine that the thing that you will need to prove will be slightly longer here. So what we need to do here is maybe we will need to equate it to 0 first, and we need to go back because we can't solve it in terms of dy dx. So which means that we need to get a value, then after that we look at the equation of the curve and to tell you that you do not have such coordinate that give you 0. So which means in this case, if let's say is assume, okay, x minus 2y. Yeah, because the denominator cannot be 0, right? We are saying no stationary point, which means dy dx equals to 0. So assuming the numerator is equal to 0, so in the other hands then, which means that y should be equal to x over 2. Okay, so you move here, then move back the 2. So y equals to x over 2. So substitute back into the equation. So we have x squared minus 4x, the y here is x over 2, minus 2y here is x over 2 squared equals to 1. Okay, so let's try to solve and see what happened. X squared, so 2 minus 2x squared, so you got 4 here, so that gives us 1 to negative square root over 4. Sorry, 1 to 4, that's 2. Okay, then equals to 1. So in this case, you have negative 3x squared over 2 equals to 1. But we know that in this case, right, x squared should be, okay, let's try to rearrange it a bit maybe, or just try to look at this. Okay, x squared should be a number that's greater than 0, am I right? So that's why when you try to multiply 3 over 2 with x squared, you should be able to get a number that is lesser than 0. So which means that this number can never be 1, am I right? So which means negative 3 over 2 square root x x squared can never be 1 in this case. So dy dx is not equals to 0, so no stationary point. Okay, so yeah, that's the idea. So now move on to, oh yeah, sorry, the marking key. Okay, so this thing got 3 marks. So what you need to do is, the idea is, yeah, you assume it to be equals to 0, because in this case we do not have other alternative to do that. Substitute back into the equation, you get another m1. So after you get this thing, then you'll be able to justify and prove everything, then you'll be able to get a1. So if you are substituting x equals to 2y, then you will be able to get negative 6y squared equals to 1. It's the same thing as well. So y squared is greater than 0. Negative 6y squared should be a number that's negative. So negative 6y squared cannot be 1. So that's one no stationary point. Okay, so part C. Alright, so find the, oh yeah, but I'll need to say this, yeah. So remember, this question is a bit different with what we have in our exam, because our exam is by looking at dy dx itself, you will be able to determine whether you have a stationary point or not. But this thing is actually not because of the dy dx, it's because of the equation of the curve itself. So that's why if you were to ask me, I'll it will still always depends on the question that you have, and you will need to try to give a general approach for the question given. Okay, so C, find the x coordinate for each point on the curve at which the tangent is parallel to the y-axis. So if the tangent is parallel to the y-axis, meaning that the gradient is infinity. Okay, so dy dx is infinity. Yeah, if it's parallel to x-axis, then it's 0, right? So if it's parallel to y-axis, then it's infinity. Infinity meaning that your denominator is 0. So the denominator here is 2x plus 2y equals to 0. Okay, so the question only wants us to find the x coordinate, so that's why it's easier for us to substitute y. So y is equal to negative x. So substitute back into the equation that we have. So x squared minus 4x, y is negative x, minus 2y is negative x, square equals to 1. Am I using the correct thing? Oh, yeah. Okay. So substitute it. Then after that, let's try to check. X squared plus 4x squared. X minus 2x squared equals to 1. So in this case, 1 plus 5, 5, so 3x squared. Okay, 3x squared equals to 1, so which means x will be equals to positive and negative square root 1 over 3. So that's our answer. Okay, so yeah, so this thing, try to if let's say you can, then just try to rationalize it lah. So which means plus minus 1 over 3. Okay, times 3, so sorry, times square root 3, so we have square root 3 over 3. Yeah. Alright, so for this question, use this thing equate to 0. Then after that, you got this whole thing correct. Then you have 1 marks for your method. Then after that, at the end, you'll be able to get your x coordinate. This question didn't really need you to, but they at least simplify up to this point. So it means either this answer or this answer are both acceptable. Okay, so that's 2 marks for this part. Okay, so yeah, let's move on to 9. Okay, question 9a is given that 2 tangent 2x plus 5 tangent square x equals to 0. So the question wants you to denote the tangent x by t, then form an equation. Okay, so the thing that we can try to do is we might need to use some formula to change, to get rid of the tangent to x first. So part A. Okay, so let's copy the equation. Alright, so now use the formula for tangent to x and substitute it. So we have 2 tangent x over 1 minus tangent square x plus 5 tangent square x is equals to 0. Okay, so now depends on you whether you want to simplify it first and only you denote, or you denote first and after that you change it lah. So for me, I find it's easier that you try to denote first. So in this case, the question say let t equals to tangent x, right? So we just change everything first, then only we simplify together. So 2t over 1 minus t square equals to 5t square equals to 0. Okay, so in this case, we can multiply 1 minus t square for everything here. So we have 4t plus 5t square. And for this one, we need to multiply t minus t square. Okay, so we have 4t plus 5t square minus 5t4 equals to 0. So what's the question one, the next? So form an equation in t. So this is our equation. So show that either t equals to 0 or t equals to cube root t plus 0.8. So which means that we need to further simplify this. So the first thing that we can do is simplify everything by t, I guess. Oh yeah. So we can take out negative t. So what we have inside here is 5t. I use this chance to rearrange everything as well, yeah. So 5t cubed and then minus 5t. And then for 4t, then we have minus 4 equals to 0. So in this case, negative t equals to 0, which means t equals to 0 lah. Then the other thing that we have is 5t cubed minus 5t minus 4 equals to 0. So I'll try to rearrange them a bit. The question one cube, so that's why we only left with 5t cubed equals to 5t minus t. Okay, then divide whole thing by 5. Then the cube become cube root. Okay, so yeah, you already show it. So that's basically part A. So how are the marks given in this question? So the first one is you need to use the correct identity here. So which means for this part, then you'll be able to get the, yeah, so the identity part, use everything here. That's give you your M1. Then after that, you successfully change everything, then you'll be able to get this equation. Then you can get your another A1 here. Then after that, you equate them, then you try to factorize it, then you'll be able to get your M1. Then the last one, t equals to 0, and also the last part here. So the whole thing here give you another A1, so 4 marks. Okay, together, this thing and this one. Okay, so now the next part, part 2. So it's given that there is exactly one real value of t satisfying the equation here. So verify by the calculation the value lies between. So this is the sign of change that we need to prove. So b, okay, t equals to cube root t minus 0.8. So please remember, you must try to arrange and put everything to one side equals to 0, then only you can change it to fx. Okay, equals to 0. So f of t in this case is equal to t minus cube root t minus 0.8. Okay, so that's 1.2 and 1.3. Then you'll be able to get 1.2 minus, is it plus or minus? Do I do any mistake? Oops, I'm sorry, just now here. Yeah, this is supposed to be plus. Yeah, okay, plus. I think the question gives us, yeah, it's plus. Okay, sorry, my mistake here. But everything is correct. It's just that when I moved it, I forgot. Yeah, so plus. Okay, so then this thing is correct already. Plus 0.8. So this is plus 0.8. Then gives us 0.0599. So when you substitute 1.3, and you'll be able to get 0.0194. Okay, so that's why don't forget your last verification. So sign change, okay, indicates roots. between 1.2 and 1.3. Okay, so for this part is only 2 marks. So the same thing is consider the sign. So make sure you got your answer here. So verify your last answer. Okay, A1. So make sure you need to write the thing of sign change. Sorry, wait. Oh yeah, this part you also need this as well. Uh, I think that's okay. Yeah, so your A1 here. Okay, because you must have this correct. So you must make sure that this thing is correct, then only your M1 makes sense. Yeah, so make sure that you have written down this as well. Okay, so now the next part, part C. So carry out the iteration, I guess. Yeah, then give your result for each of the iteration up to 5 decimal places, then 3 decimal place for your last answer. I don't think I'm going to write everything here, but I'm just going to write down my working here. Then you can, just check through your answer because I guess you should be quite familiar with this already. Then every time it's the same, right? So we doesn't really need to do the whole thing again. So I'm just going to fast forward this part. Alright, so for this question, the thing that you need to show is the first one. So make sure that you have everything. At least you got the first iteration. Then yeah, just for that easy, then you can use get your M1 ready. Okay, so make sure that the point that you use here must be a coordinate that's a value that's between 1.2 and 1.3 because what you're trying to do is you are finding the root between 1.2 and 1.3. You can start with any number, but just make sure it's in this range between 1.2 and 1.3. So it'll be safer to just start in the middle lah. So if you get one, then you can get it. Then after that, your last answer you get 1 mark. So make sure that you show enough iteration. So I'll say it's good to have at least in this case, I think I show 6. So make sure that you have enough iteration, or the other thing is make sure that you do this lah. So I'll say better do both lah because sometimes the marking key just give like show sufficient iteration. It's very hard to say what is that meant by sufficient. So that's why this is your A1. So your M1 will be depending on whether you show enough sufficient iteration or you show the sign change in these two interval, then you get another M1. Okay, so that's 3 marks for the question. Okay, so next part. Okay, last part of the question, using the values of t found in previous parts of the question, solve the equation here. So yeah, you must remember that you still have a t equals to 0 here, yeah. So if not, then later you'll kind of miss out something here. Okay, so for part D here, so let me try to just copy down the equation first. So 2 tangent 2x plus 5 tangent square equals to 0. Okay, so in this case, we have t equals to 0. Then just now we have t equals to square root 3 t plus 0.8. Okay, so you will have which means just now we know that t is equals to tangent, right? So that's why later we might need to solve for tangent equals to what lah. So in this case, it's tangent x is equals to 0. So you need to find out your x. Then for this case, just now we solved already, right? It's 1.276. So which mean tangent, you can write down your solution first, I guess. Okay, so for this one, t is equals to 1.276. So that's why tangent x is equal to 1.276. So what is the interval given for this question? Uh, you need to solve it, yeah, from negative pi to pi. Okay, so yeah, that is important. Okay, so in this case, then the first one you have tangent x equals to 0. that will give you x is equal to, you can try to imagine your normal tangent graph. Okay, so like this, then should be this part, because you only need up to that up to pi, right? So it's like this. So when it's equals to 0, then it's this point, and this point. So it's supposed to be negative pi, 0, and also pi. Then for this one, you can use your calculator to just solve it. So tangent x equals to 1.276. So the x, the reference angle, should be equals to 0.906. Then the other one is the quadrant 1 to quadrant 4. So sorry, quadrant 3. So that's why it's supposed to be negative pi plus 0. I hope you get what I'm doing here. Okay, let me try to just do a quick one. So x is equal to 0. And 2.44, negative 2.24 for three significant figures. So that's your two answer. So why is this two? So we know tangent, right? So now we are talking about from 0 to pi. So that's why you have one answer is over here. So this is your 0.906. Then from negative pi, so negative pi starting from here, right? So AST, so that's why it's here. So this is 0.906. So you want to get what is the angle here. So you will get negative pi. Negative pi is the whole thing. Then you minus off 0.906. Then you can get this part. So this is how you get the two answer here. Okay. So for this last part, you will have the marks of 1, 2, 3. So 3 marks. So evaluate your tangent. So obtain 0 point. Yeah. So for this part, you will get 1 for A1. Okay, your last part here, B1. Then after that, you understand that you need to solve for these two. So which means if you are able to write down tangent x equals to 0, tangent x equals to 1.276, then you'll be able to get your B1 here. So that's 3 marks. Okay, so let's look at the last question. Okay, question 10. Liquid is flowing into a small tank which has a leak. Initially, the tank is empty. So which means when T equals to 0, the volume is 0. So after T minutes later, the volume of the liquid in the tank is V. So the liquid is flowing into the tank at a constant rate of 80 cm cube per minute. So because of the leak, the liquid is lost at the same time at any instant is equals to kV. So write down a differential equation describing this situation and solve it to show this thing. Okay, so the first thing that we need to do is to identify our differential equation first. So the thing that we have is the rate of liquid in the tank. So that's why it's supposed to be dV dt. Okay, so we can see that the liquid is flowing into the tank at 80 cm cube per minute. Then after that, liquid is being lost. So the speed that it's being lost is kV. So that's why it will be 80 minus kV. I hope you get what I mean. This is the, I mean, water, you can imagine it as if like in an easier way as, okay, water is flowing in with 80 cm cube. Then if I tell you that water is going out with 20 cm cube per minute, so which means that 1 minute 80 come in, 20 minute go out. Then which means that how much is the real increment in the tank? It will be 60. How do you get 60? Because you're flowing in 80, you're flowing out 20. So that's why 80 minus 20, you get 60, right? So it's the same idea now, but it's just that your kV is like a kV rather than a 20. So that's why just 80 minus kV. So you can get the rate of change for the volume of the liquid in the tank. Okay, so now we have our equation already. Then we need to continue to solve this differential equation and to get this thing. So I guess this will be a bit difficult because you can't split that. So which means you need to bring the whole thing to the other side. So yeah, I guess that's the only choice that we can do. So bring the whole thing to the other side. So which means we have 1 over 80 minus kV. Okay, so dV, we can bring the dt to the other side already. So you left with 1 dt here. Okay, then integrate. Okay, so after we get this, then in this case, then you can see that if you want to integrate this thing, then it will be in a form of ln, because you can see that you have something like e here, then definitely you can try to guess what will happen next lah. Okay, so which mean if you want to use ln, then which mean it must be f prime x over f of x, right? So your numerator here must be negative k. So now is 1, so which means that you need to multiply negative 1 over k outside. So which means negative 1 over k and then negative k. Oh yeah, please remember you can only do this if your k is a constant, yeah? If let's say your k is like a variable, you can't do this. So k is a positive constant. So k is a number that we are going to solve later. So that's why in this case, this is like a normal number, so you can do that. If let's say k is like a variable, then you can't do that. Okay? Because you can't simply multiply a number like this. So equal to, yeah, we can just copy it first. Okay, so now we can try to start the integration. So negative 1 over k ln. So what we have here is 80 minus kv. Okay, I hope that you can see it. So basically 80 minus kv, after you differentiate, then you get negative k. So that's why f prime x over fx then equals to ln 80 minus kv. So equal to integrate 1 with respect to t, then you get t plus c. Okay, so when just now we said when the time is 0, then the tank is empty, right? So v equals to 0 from the first sentence of the question. Okay, initially the tank is empty, so that's why t equals to 0, v equals to 0. So let's try to substitute. So negative 1 over k ln, so you left with 80 here, equal to 0 plus c, so c. Yeah, this is basically your c lah. So after you get this, then if you want to write complete stuff, then yeah. Okay, so minus 0 and equals to 0 plus c. Then let's copy it again. So c equals to negative 1 over k and ln 80. Okay, so after you get this stuff, then we substitute back into our equation here. So negative 1 over k ln 80 minus kv equal to t minus 1 over k ln 80. So you can try to imagine what the question wants us to prove here. You do not have any ln anymore, but you have one e. So imagine what they try to do is combine the ln together. Then after that, you bring to the other side, then you become exponential, right? So you can imagine what happened there. So in this case, then what we can try to do is change everything to ln. So multiply k first, I think. Multiply negative k, then we have ln 80 minus kv equal to negative kt minus ln 80. Yeah, then this will be easier. So either you want to group these two things together also can. So let's see, 80 minus, it's okay, we don't group them together. I think we can try to change everything to ln. I guess that will be easier. So 80 minus, but you can try out the other way. So ln e negative kt minus ln 80. Okay, so in this case, these two can be combined. So that's why we have 80 minus kv. So make sure it's divide, yeah. So e negative kt over 80. Is that okay? Yeah, so after you get this thing, then am I doing anything wrong? It seems yes. Yeah, this part. Sorry for that. So negative, multiply negative k. So this should be plus. Okay, so that's why let's try to do step by step. Okay, so we have ln 80 here, so which means it will be multiplied. So ln 80, then multiply with this thing, then we have e negative kt. Okay, so ln, no need to write that anymore. Okay, then go back to the question. So v equals to 1 over k. So the thing that we left is just group them together, I guess. Yeah. So kv is equal to group these two together. So 80 minus 80 E negative KT. So we have V is equal to 1 over K. So 80 minus 80 E negative KT. So that's proof. Okay? Yeah, so that's basically the idea. It's a bit long for this question because it's like a 7 marks question. So the first mark is given if you successfully get the differential equation that's B1. So separate the variable, then you try to do integration, then which means in this case, then you'll be able to get your M1 here. So successfully to get this term, then you'll be able to get 1 here. So I'll just write down here. So 1, 2, the whole thing here. Okay, that gives you A1. Then after that, substituting your 0 and everything, then you'll be able to get your C, then you'll be able to get another M1 here. Okay, then after you substitute, then put it back to the equation, then you will need to, do some arrangement and so on. So let me try to see where's the marks given. 1 over K ln K. Yeah, until this part. Okay, so after you multiply with negative K, then you will be able to get like 1 over here, substituting everything inside. Okay, then 1, 2, 3, 4, 5. Then the next part is you understand how to change all your ln thing, so make it to non-ln, so it's here. Then until you get your last answer, then you can get your A1. Okay, so that's basically the whole thing. 1, 2, 3, 4, 5, 6, 7. Okay, so now let's move on to the next part. Yeah, it's going to be another iterative again. So it's observed that V equals to 500 when T equals to 15. K satisfy this equation. Use an iterative formula based on this equation to find K correct to two significant figure. Use initial value of K equals to 0. Okay, so in this case, you're only given this, so you need to write down the end thing by yourself. So let's start with a new page here. Okay, let me try to copy down the equation first. So it's given K equal to 4 minus 4, is it theta? E. 4E negative 15K over 25. Okay, so you need to write down the iterative formula by yourself. So which is Kn plus 1 equal to 4 minus 4E negative 15Kn over 25. So question already give you that set your initial value as 0.1, then show every iteration up to 4 significant figure. So you just continue to do everything lah. So same thing, I'm going to fast forward this part. Okay, so basically for this question, same thing here. So, but the only difference is that because the iterative formula, you need to do it by yourself. So that's why you are given like 1 marks over here after you get this. Okay, then after that, you start to apply for at least one. So that's M1 here. Then after that, write down your last answer here, 0.1 for you get 1 mark. So same thing, this is or even you show 1, 2, 3, 4. In this case, I show 6 here. Okay, or you do justification here so you can get M1. Okay, so I'm not going to repeat the thing again. It's the exactly same thing. So 3 marks for the question. So let's move on to part 3. Okay, so determine how much liquid there is in the tank 20 minutes after the liquid started flowing and state what happens to the volume of liquid in the tank after a long time. Okay, so which means we already got the equation for V, right? So we need to substitute T equals to 20, then we can get how much liquid in there lah. So by using the equation of V that we have here. Okay, so this is a thing. Then you have gotten your K by in part B, right? So that's why you just substitute inside. So sorry, this is C, not part 3. Okay, so part 3, so sorry, C. So V is equals to 1 over K and then 8t minus 8t negative KT first. Okay, so you have the K here. So it will be good if you can use like the full value here. But in this case, I think the marking key give you a range to follow. So that's why it's still considered okay. So because if you continue the iteration, right, you'll realize that the K will converge to 0.1406. So it will be helpful if you can use a more accurate answer for this. So in this case, we will just try to use if you try to use 0.14 at is okay as well because the question give you an answer for inclusive. Later I'll give you as well. So 80 minus E negative 0.1406T. Okay, so let's try the first one first. So 20 minutes. So make sure you check it back here because the question here is the time here is per minute. So that's why we know the T here means minute. Then we just substitute. You don't need to do any conversion. So 0.1406 8t minus 8te 0.1406 times 20. Okay, then from here, then you'll be able to get round it to three significant figure. You'll be able to get 535 cm cube. Okay, so that's the answer. Then after that, yeah, let me try to write this down first. So this is 1 mark for the 20 minutes. So the answer key actually give you a range. So which means any number in between 530 until 540 is acceptable for the answer. Okay. Yeah, but I mean, this is the accurate one. Okay, then after that, the next part is after a long time. So which mean in another words, when your t is approaching to infinity. So the thing that you can try to do is you press with your calculator, slowly increasing your t, then you'll be able to see that it converges to one value. So if not, then the other alternative that you can try to do in this case, because you already have E negative, then it will be quite easy to do this thing. So when t approaching to infinity, then which mean that E 0.1406t will be approaching to infinity as well. Okay, because exponential graph, when your x increases, your y will increasing as well. So goes to infinity. So that's why this part is 8e over, right? So because it's negative, so E 0.1406t. So that's why if this thing approaching to infinity, then which means that when you use something to divide something that's infinity, then this will approaching to 0. So when this thing approaching to 0, when you try to put inside, then which means 0.1406 or 80 minus 80e negative 0. Sorry, let me try to write in the form where we have just written. Okay, 80 over e. This thing will be just approaching to 1 over 0.1406 and then 80 minus 0. Okay, because this thing is approaching to 0. So which means what you left here is 1 over 0.1406 multiplied with 80 lah. Then you will be able to get for a long time, then the volume will be approaching to 569 in 3SF. Okay, so same thing, the question also give you an inclusive answer for this one. You can get the last answer. So which means if let's say you really don't understand this approach, then you can just use your calculator, slowly increase your value, then you can get the same answer as well. So for this question, this is the accurate answer, but the questions allow any value in between 567 to 571. Okay, so that's basically the last 2 marks. Alright, so I hope that you can understand everything that we discussed here. Sorry, it's a bit long, yeah, because of the explanation. But let me know if you have any questions. So basically, that's the part for difficult set 1. Okay, thanks for watching. Okay.